Good afternoon, everyone. This is Tulika here. And what we have designed, what we have planned actually, this is something we know that blinds always use brailles and other not technologies, other methods for reading and writing. So this is a technology which we all use, like touchscreen and smartphones and everything we all use. But blind people are unable to use those kind of things because they have to visualize the thing and then click on it and do other stuff, because with touching they can't do the work. And if we see our mobile patterns, we have 9 dots there for unlocking the page or anything you do. You have 9 dots for password protection and everything. But for that also, a blind person needs to check whether the 9 dots are correctly matched or something like that. Being a blind person, we can't expect them to have that pattern matching. For that reason, what we have planned, we have a touch screen. It can be of this size, it can be a very small device, anything can be there. And if they propose to give or switch on the light, they can give a simple L, which we have programmed in the microcontroller. It's a small L. It can be given at any position in the touchscreen. They don't have to match the pattern and then give it. So at any position of the touchscreen, if they put a L, the lights will get on. Then for switching it off, again they can give an L. So first time it will switch on, second time it will switch off. I know blind person doesn't need a light, but a person who is entering the room of the blind person, they might be requiring this is the main system flowchart which we have designed. HAB is for home automation for blind. So for that, it's just a flowchart which is very much clear. We start the transmission. We have 2 devices in our project. The first device is to transmit the signal, and it is a wireless thing. So we have a device in hand which will be having the touch screen, and the patterns will be given by the person. And the second device which will be connected is the wireless device, which will receive the transmitted signals, and then accordingly it will switch on, switch off, or any other devices. So for that we need a serial timer and initial timer. Timer is required because first thing, if we give a L, first it will switch it on. But again, it's a toggle position. In technical term, we can use it as a toggle position. First high, it will be on. When it is low, it will be off. So that technology we are using. Then to get X and Y positions, what we have designed in a device, I'll just show it, I'll just draw it. Suppose this is the touch screen, and we have few, this is the x-axis, this is the x-axis, and this is the y-axis. Now, how we have positioned is anything which is going right hand side. So these are the areas which we have taken. In this project, we are using resistive touchscreen. There are capacitive touchscreens, which our phones, present phones, we are having capacitive touchscreens. But in our project, we have used resistive touchscreen just to check the prototype. In the resistive touchscreen, what happens? There are 2 electrical conductors and 2 thin film like this. 2 film are there, and it is separated by a gap. Now, when we press on the touch screen by our nail or anything, in that a voltage divider is created, and this position we get a voltage value, because the 2 conductors are touch at this position. Suppose like this, it gets touched. So that voltage we have converted into digits, and those digits we are taking as our values, and those values are the X and Y positions. In the next slide, we'll go see the detailed pattern matching thing. Now, when both positions are in limit, if we have already feeded the microcontroller with some position of our own, and when that positions are fitted, we just see whether that is in our limit, because this touchscreen, if we are putting an L like this here or an L like this here, it is in our limit. So that thing is checked there, and then we store both the positions, both position in the sense X position and Y positions, and is gesture entry over or timed out. If the gesture entry is correct, because maybe we have 5 appliances at home, so we will put L, F, and other 5 things which the patterns which we want. So is it within the gestures which we have already fed in the microcontroller? If it is in yes, we'll go to the next step, or else we'll again get the position of X and Y. So we'll then start processing the gesture and then convert the points into unique directions. Now what we are doing here is, first we are getting the positions in the form of voltage, that is the voltage divider with the values which we are getting. We are converting those things into some values, and those values we are taking 5 units of those values. Suppose 25 values we are projecting for L. So this is one value, this is one value, another will be there. Any place we give like this 25 to 30 values we are providing. And those things we are converting into a block in the program, and then we are generating one single block for the 25 values or 30 values, how many we want. And then those blocks are loaded into the pattern for each device, and then again the pattern is compared with the stored pattern which we have already fed, and if the match is found, the code is transmitted to the receiver part, and then the lights get on. That is the main purpose of that is the main flow diagram of this main system. Now, this is the pattern matching algorithm. In this, what I was actually trying to show that time, this is more clearer. Suppose we have one, you can see the number 1, 2, 3, 4, 5, 6, 7, 8. So on the touch screen, we have assumed that we will be having these kind of directions. One can be up, one can be down. You can see the up, upright, right, down, right. Those values, corresponding directions are given down. So suppose we want to draw an L. How we are drawing it? A normal person will draw the L like this and then like this. So in this case, we take 5. The downward position is for 5, and this side is 3. So those values are fed, and those are the design through which we can get the pattern matching for X and Y positions. So different pattern will have different kind of values, and accordingly we will configure it in the program. And this is the pattern matching flowchart, how we are doing it. So we'll start the pattern matching. One thing is already configured in the microcontroller, which needs to get matched with the thing which we are providing. So we'll convert all the points into unit directional vectors, and in the function you can see dv equal to get dir, x1, y1. x1 is the positive one, x2 is the negative axis, y1 is the positive y-axis, and x2 is the positive negative y2 axis. Yeah. So that is the thing. And then the next thing is take a group of 5 directional vectors and find block direction, which is effective direction. So we can take a block, as I told, at 25, 30, how many numbers you want, and then you can group it up together and get a block. So that is the function for the block, bd equal to get block, and 1 to 5 I have taken, so it is I plus 4. So every time you change it, it is 2 plus 4 and whatever. And then match generated block direction with the pattern database for various shapes in various sizes. So you can see the match is generated, what is fed and what we are giving. So those things has to be matched and from the database, and we get the various shapes and various sizes. So if the match is found, we send the RF code to the application part. As I told, we'll have a transmitter part and the receiver part. So we'll send the RF code to the application part, and if match is not found, again we'll wait to generate the next thing. So this is the small block diagram. What are the equipments we are using for the portable assistant? One is the 4-wire resistive touchscreen. 4-wire resistive touchscreen we are using because it is easily we can connect it to any computer and download the programs. That is for the 4-wire resistive touchscreen. Just for the prototype, we can modify with that capacitive touchscreen and everything. Then a touchscreen controller, which in this project we are using MSP 430 because it uses very minimum power, And then the configuration which we have already feeded to it, that is the shapes and sizes and everything is feeded. And the location independent size tree shape identifier, that is any location, any shape is identified, that algorithm is fitted there. And audio visual indicators we have just added because a blind person cannot see text messages and anything. So we can have in the prototype we can use this SIM, GSM SIM, and we can use audio visual indicators for that, because if a person wants to call at any person, just by seeing if they call, the emergency contact can be contacted at that time. So that are the audio visual indicators. And wireless communication driver, that is the wireless part from transmitter to receiver and the wireless transmitter. And this is the receiver part, which has 16:2 LCD. LCD is not required for the blind people, but why we have used it, because for our for us to check whether the light is going on, whatever it is, we have just used it here. Then the main controller, the GSM modem, as I have told, that for the message sending and everything, or call, you can just, for S, if you give S, some emergency message will be going, which will be fitted in the program. And also for the call, wireless communicator driver, from the wireless receiver will be having a wireless communication driver, which will be also connected to the main controller, and basic input and output what we are giving. And high current interface, just because we are using high current appliances, so we need an interface for that. And direct device control via relay. Relay we are using because for the toggle thing, if it is first time, if you give an L, it will switch on, the next relay it will switch it off.
Last 2 minutes.
Yeah, these are the various types of development kit for the MSP 430. You can see we are using this one, the present one. These are the just the overview of how the microcontroller looks for the project. And this is the flowchart of the application part. I have already explained it, that serial timer, how the code are received and validate code. That is the actual full application, whatever is happening from the main system to the transmitter and the receiver. And everything has some disadvantages in the beginning. We have to upgrade it, that's all. And that is the future scope. We can use different touchscreens and all that. And the references.
Very good. Very impressed. Very impressed with this. Very impressed. What I want to know is that do you have a prototype now?
Yeah, I actually have it.
You have a prototype?
Not here. I have it. I made it. I didn't get it.
You have a prototype?
Yeah.
Achha, number one. Number two, have you considered it to be the basis of a business model?
Not as of now.
It's an innovation now.
No, so I'm coming to that. Therefore, you see, you have to then think in terms of a business model, because you cannot just leave it as an invention. I would like to differentiate. It is not yet an innovation. It is an invention. So you have to now give it certain features which will make it a possible viable proposition, a viable product. And then you have to think of the business model. Okay. And then I'm willing to, if I see that business model and if I see your prototype, I'm willing to become an angel investor in this project.
No, at first, sir. One point you are missing.
No, I'm coming to that point.
She has to get a patent of that.
No.
Otherwise, man is sitting over there.
I'm coming to that point only. The idea should not get.
Get a patent of that.
Yeah, the idea should not get transferred elsewhere to other
technology.
technologies.
If a man is sitting in such a way, just now you should take that idea.
Yeah. So I'm serious, really serious. Very extremely interesting. So I think when we get back, I would like to see the prototype, and then I want to look at what is your business model. Business model for the innovation. You are at the lab stage. You are at the lab stage.
Yeah, applied with any blind people. This one, that your prototype.
Question.
I have not tested on any, but myself, I have worked on it, and it is.
You must taste it. That
Yeah.
whether it is
You,
foolproof or
Tulika,
not.
you
Isn't it?
just go ahead. All our department will side by you. No problem.
Thank you.
So I'd like to praise your innovation
Thank you, sir.
in finding solutions for ways that blind people can live more conveniently. I would strongly suggest that to be successful as an entrepreneur, to look to the next step of, or the next level of technology, which is voice recognition input as opposed to using touchscreen. I actually have voice recognition hardware with software that does what you're doing already. So what you would need to do to make this, you'll have to think about what you can do to make that technology as innovative and helpful to blind people as what I already have and what you're already doing.
Yes. I'll think about it, and I'll obviously contact you.
Okay, I can share my experiences with my very small smartphone, smart home.
Okay.
Yeah.
Sure, sir.
Yeah.
Any
Yeah.
Yes, madam.
no.
Yeah, and you are going to ask something, please.
Ma'am,
Then I
ma'am,
can-
you ask.
Yeah, you can.
Okay, only one suggestion. Actually, this is a very good, invention, and these products can be sold in the market for sure. I guarantee that. Only one suggestion: your touch screen cannot be low cost touch screen.
Yeah,
Yeah.
that is for the prototype I have used
Yes.
just for testing, and I have told in the future scope
Right.
that we can use capacitive touchscreen, which we are using in our smartphones at this moment.
Yes, you have to use the IP40 before or something. You have to industrial proof touch screen because safety of the blind person is
Yeah.
very important. So that is can be
That's
said.
it. Very good
Thank
question.
you.
The question is that, are you thinking of, say for example, if you consider your business model, whatsoever you have thought of, are you considering you are exclusively trying to manufacture this kind of cell phone to the blind people only? Or it's a cell phone that can be used both by normal people and visually impaired people?
Sir, actually, this is not a cell phone which I have designed. It's just a device. I don't
Right.
have all the functions which a cell phone or a smartphone does. Those things needs a lot of more application part, and everything is there, and I have not worked on that at all. It is just a simple touch screen which is only recognizing the patterns. That's all it is doing. It is not doing any other work. And GSM port we can just insert in the material. That is just for calling and receiving, and that too, it will not be calling any kind of any number or anything. We can't call only the number which is feeded as an emergency contact. That number can be contacted if it is C, or if it is S. C for call and S for SMS, like that. Only one single number which is already feeded in the program, not any other calls. But because mobile technology is something very complex, which we have not included in this.
Okay.
So-
The basic purpose of this device is to just inform, for example, a visually impaired person tries to inform somebody that I am just calling you for a help or something like.
Yeah.
If
Just
I
because
have
of
understood it
emergency.
properly, this is the utility of the particular product. Okay, fine. So if this is the basis of the particular product, then the way you are thinking of improvising it, what additional inputs can be put over there you are thinking about?
Firstly, I want to change the touchscreen, which ma'am has also noted, because my testing purpose, and I was not sure if it is going to work, so I didn't work on a costlier touchscreen. I have used a very
No,
simple.
I need to say improvisation in terms of the attributes of the product.
Attributes of the product, as of now,
Because the basis, the main objective of the product is ready.
yeah.
Okay, for a visually impaired person, he or she is trying to send an emergency or SOS kind of. Okay, what additional inputs or what additional attributes from marketing point of view I'm discussing? Okay, from what additional inputs or improvisation you want to make over here, you want to add into it.
Suppose I'm using the device within this room. I'm sitting at this corner and I'm switching on the lights and fans of this room. But as I have mentioned that it is from 20 to 50 meters range it will work. I want to make the wireless device in such a way that if I sit in the 20th floor of this building and I want to switch on or I want to open the gate of the ground floor because my guest is coming into the home, into my home, so that thing can be done. That technology I have not yet worked on. So these are the things, like range is one of the things, touchscreen is one of the thing, and maybe voice recognition also, which sir has also mentioned, that voice recognition I have not included here because many devices in blind, for the blind people which is designed is having voice recognition. So that is not anything innovative which I'll be doing. So that I just need to add on. So these are the things I can more improve the device
Okay.
for the business perspective.
Yeah, from that only one small comment.
Yeah.
That you see, you need to seriously think on what Professor Sanyal is saying, because for a business model to be viable, you require scale, and the more attributes you can put in the product, the possibility of scaling up will become higher.
In terms of sales in the market.
Yeah.
Scale it is at nascent stage.
But very appreciable.
You have to incorporate all those things.
Dr. Chanel, you also
And,
suggest some,
we-
you also suggest some attributes so that it can be sellable in the market.
Yeah, anyone who is having any
Tulika,
other-
Come
I
up
have
with the
one
ideas.
question.
I believe that this particular situation on the current platform of
No, in the
solicitation.
different platform you just
Yeah,
added.
definitely.
Obviously, now. Yes,
Okay.
Tulika, I have a question.
The
Tulika,
last question.
okay, last question. Just maybe it's not a question, it's more of a suggestion. Have you thought of putting into braille letters into this particular device?
No, not really, because I have what is already there. I don't want to work on that. I wanted to do something.
So I think if you are putting an additional braille letters, it is easier for the blind people to actually get hold and it's just the screen. If something of braille letters can be put into it.
Essence of the device which I'm already.
Okay.
Specific.
Okay.
Very specific.
Okay.
Very
Okay.
good.
Thank
Very
you.
good. Very good. Very good. Very good.
Next paper comes is the brain